Okay, I'll start now. Good afternoon to all the tech enthusiasts present here. My name is Rachita C, and I'll be presenting this webinar on the topic LangChain agents. So, without further ado, we can get started. So, we are in this era where everything is about generative AI, and it is so powerful, and it is able to understand the human language, and also it is able to generate the human language. It has become so powerful, and we can talk about it, about this LangChain and about this generative AI on and on. But the question is how to utilize this power, or how to harness this power in order to tackle the real time or the practical task. So there are many such way to do this or to accomplish this, but one of the ways is to work with LangChain agents, about which I'll be talking about now. And this LangChain agents is an innovative framework that serves as a bridge between the huge capabilities of LLMs and with the automation action. And by this automation action and all these capabilities of this LangChain agents, it is able to accomplish so many practical scenarios and so many real-time tasks, in a very effective manner. So let's talk about LangChain. So LangChain is a pioneering framework that connects between, like it acts like a bridge between this huge capabilities of LLMs and automation of the real-time tasks. So it has various applications in each and every domain, and we can also talk about the complexity levels. It starts from the basic customer service complex level into up to this automation of complete process. This LangChain proves very good and very effective to be tackled when it comes to these practical scenarios and real-time cases. So let's talk about the components of the LangChain. So we can see in this diagram, about the whole work process of LangChain under the hood. And let's talk about the schema. So schema is a basic structure of, in order to organize the type of the data which inside the code. So we have a text schema wherein the user will text, message or write a form of in terms of words into the model and serve it and get the output from it. So the model recognizes the text, finds the pattern, and do the relevant task. So we also have chat messages wherein the user chats with the model, and the model will recognize the previous history chat and the current chat and will give the relevant response. And we have a document schema wherein the text or document is presented as a schema, and based on that the user can get the response from it. And we have an example schema wherein we can provide some examples to the model, by which it uses this example schema to come up with a more relevant and more customized result based on the examples given. So the next component of this LangChain is the models. We have the language model to understand and to generate the human language, and we have a chat model wherein it is used to do the conversation between LLM and the user. And we have an embedding models where the all the documents will be stored, and based on that the relevant information will be retrieved. And the fourth one we have is indexes. So this indexes acts like a link between the LLMs and the document. So we have a document loader wherein all the documents will be stored, and then we have a text splitter wherein all these documents can be splitted into different chunks, or any key value pairs if it is any CSV file. And then we have a vector store to store all these things, and then we have a retriever to retrieve all the relevant information based on the user query. And then we have a memory component, which is very important for the LLMs to understand what is going on all around it, and what is the query is about, what was the previous query about, and it gets this connection between two queries. So memory is also very important. And the chains, it links different parts together inside the code in order to make things way better. So this is about the component. And the last component is agents, about which we'll be talking in the further slides. So let's talk about these agents. Varieties of use cases such as answering the question, generating text, translating languages, summarizing text, and so on. So this LangChain agents are built to interact with this real world, and they're a very powerful tool. They have tools, toolkits. They have this memory component. They have agent executor, about which I will be talking in the further slides. So all these things make these agents so powerful in order to tackle real-time scenarios, and to get more advanced results, or more enhanced results, I can say. So this is about agents. And what is this buzz all about? Like, why are we talking about this LangChain agents? So as we have already discussed about this different applications of it, like as we can see on the screen, we have advanced Q&A system, constructing a chatbot, or it may be dynamic content generator. So all these things can be made or can be built using basic LLMs. But this LangChain agents has its own differentiator from the rest. We can get a more customized result. We can automate this whole process, and we can, I can say, we can put this virtual cap on the model and force the model to think under certain direction in which we want, or we can get the desired, most desirable output by doing this customization or having this customization. So this is how this LangChain agents will differ from the basic LangChain models or basic LLMs. And it is way powerful, and we can get enriched and more enhanced result by using this LangChain agents. So this is the block diagram we can follow. In this agent chain, it will uh, gather all the parts of the code and put it together as a chain, and then it selects which is the type of agent to be taken into consideration as per the code, and then it takes the action input, and it, based on the query, it does all this observation work, and it goes through all this thought process, and all these things will be done within the model, and it will come up with a final answer, and it will finish the chain. So this is the basic block diagram of uh, LangChain agents. So coming to the difference between these agents and chain, so the main differentiator is the chain involves just the sequential calls, which focuses mainly on this computation and the information flow. Whereas this agent, this prioritizes this decision making and environment interaction. As we have seen in this slide also, we have this huge process of decision making. It doesn't just throw out the result or just put it out to the user that this is the result. It has to go through this observation, it has to go through the thought process, and it has to go through that the dilemma, if this is a correct or not information, it is correct or not. So all this process it does, and it comes up with the final answer. That is how this chain is different from this agent. And coming to the core conception, so this agent utilizes this LLM in order to determine actions, while this chain is hard coded to to do the actions of sequences. And functionality says agent will be using these LLMs in order to make the decision making, action taking, and result observation. And all this iterative process will be done in order to get good and desired outcomes. So as you have discussed earlier as well, so we have several applications in this. Let's say it can be question answering and personal assistance, chatbots, data querying, evaluation, and so on. And this talking about these components, this agent integrates this LLM as a reasoning engines, and also connecting them with the tools and memories, and in all these things are done to enhance the functionality of this of the result by using this LangChain agents.
No, but Rachita, I used to think that even agents can create the effect of chains, so agent chaining, if you will.
Yeah, though this is differing from the chain, as in, see, it goes through whole process of this action, input, observation, and thought. So it might, and also we can see this what is happening under the hood, what observation is taking from the input, and what is it looking into in in actual scenario. So all these things we can see transparently using an agent executor. So this is how it differs from the basic thing, and we can have the complete control over this whole process when we use action agents, LangChain agents. So that is how it differs.
So another question is how the agent is different from a chatbot in or any kind of bot.
Yeah, so we'll be coming to this part in the further slides. I'll be discussing about this. Is it fine if I answer this later?
Yeah,
Okay,
yeah.
sure. So coming to the tools and toolkits, so this is the main part of this LangChain agents. So the tools are built or customized in such a way that we can do specific tasks and such as fetching the data from external sources and processing information. So all these things can be customized using tools, and based on your use function or use cases, we can build your own tools by which, with the help of which, we can also generate some very useful results. And toolkits will have all these things working together in order to enrich the capabilities and functionalities when it all works together. So this is about tools and toolkits. So you asked about how this how this LangChain agent is different from LLMs. We can have this tools and toolkits inside this, and we can have a memory component inside this, about which we'll be talking later. And all these things we can see on the screen. Why do we even need this tools? So one is this access to external resources. For example, if I'm doing any query, I want some external information to be used, so this tool can do it. We can force the model to use the tool and to get this information, and we can process the data, we can clean the data, and also manipulate the data using these tools. And coming to this integration with other system, for example, if I have a query saying, I want from certain database, I want to fetch certain things, so this tool can link with a certain database also, and it can integrate with it and then take the result, or retrieve certain and relevant information from it. So this is about the customization of tools and its extensibilities, and this is how it differs from the basic LLM techniques. We can have this, we can put more things inside this to make this make the code or make the description, or we can give more instructions to the tools to be followed. We can basically, we are pushing the model to think under think in certain direction. So that is how it differs from the basic LLMs.
So is there any alternative at all to agents? So let's say I want to use LLMs for a workflow orchestration or data integration. I mean, there's Llama Index and all the other things, but
Hmm.
apart, so before agents came around, you could not use LLMs in a workflow process at all. Is that a correct statement? Or there were alternatives to?
Yeah, this is one of the ways to tackle this situation wherein we are dealing with this problem of practical scenarios.
No, were there any other ways to achieve what agents do with LLMs?
Uh,
I mean, I am not aware of it, but maybe in your research you came with other techniques which existed pre-agent era.
I don't have answered right now, but
Fair,
we
fair
can
enough.
think about it later. Yeah.
Yeah, even I have not found anything else
Uh,
which can do this. I mean, there's just LangChain agent, there's Llama Index data
yes,
integration. Those are about it, what we have seen so far.
yes. That mostly it is not much effective as this. I can say at this point.
Okay.
Yeah.
Yeah, Vivek, Google says that agent is any reasoning mechanism based on an LLM. So underhood is LLM, it being represented as a agent through which human can interact. So human
Yeah.
may not be directly interact with an LLM or the pipeline.
Yeah.
The
Hmm.
interacting point should be an agent through which we
Yeah,
talk.
inside the instruction, inside the code, we can provide many instructions, and in some descriptions wherein we are pushing the LLMs to think in that direction only. So that is how this agent comes into play.
Yeah,
Yeah.
agent takes an instruction from the human and then the processing starts
Yes,
by the
yes.
pipe. Yeah.
Yeah. We can have some demo session also in the end, so that we can get to know how this
Yeah,
can
yeah.
work. Yeah.
And can you show me the components of LangChain once again? Maybe 3 4 slides back, just to connect with the block diagram. Yeah, yeah, yeah. So, uh, okay, it has the prompts and indexes. So these, even the index and memory is taking as a components in the pipeline.
Yeah. Yeah. That also acts like an as a component when it comes to analyzing the input from the user and giving the relevant information.
Okay, thanks.
Mm. Okay, so coming to this agent executor, so we can, as we can see in this diagram, so the agent starts the whole process, and the agent executor will see if there is a need, there is a conditional statement, if there is an actual need of the action to be taken place or not. So based on that, this loop runs. So basically, the main objective of the agent executor is to oversee all the management of the memory as well as the management of action to be taken place or not. So it takes this parameters, these two parameters when it comes to executing some actions. So this is about agent executor. So when do we need to use this executor? So when we want to have this control over the execution or execution of any actions or any memory management, so we can use this agent executor. Also, when we want to specify some tools to be used, for certain specific workflow, we want to use certain tools, we can highlight it to the agent executor to work on such only that particular tool, and also the memory component. So this is when we use this agent executor. So coming to the benefits of agent, of course, it does the automation process and make things easier. Also, it is flexible. As I said, we can push any kind of instructions related to the data, um, or how the results I want to take it out. So all those things, I want from the model to be done. So it becomes more flexible at that point. It takes all the instructions to be hard coded inside the model, and by using all those things, it starts doing functionalities in order to give a better and enhanced results. So, and coming to the reducing the development time, if it is automation, if it is doing the automation, and if it is flexible and we don't have to put much stress on it to get a desirable output, it genuinely reduces the time. When the model has all this automation flexibility, and if it reduces the time, and it directly improves, or it affects on the improved experience of the user, and take it in a positive way. So these are some of the benefits of agents. And coming to one more part of this LangChain agent is its memory. So memory is very important. It's like a powerhouse of LLMs, and it is utilized by this agent just to understand what is going on around, and it uses the memory to understand the previous interactions and to understand the context. So this is how the memory component comes into picture. And why does this agent even needs the memory? So one is to get the contextual understanding. If I'm giving some query to be to be responded by an LLM, it needs some context. If I'm giving a query to, it should understand what is the context going all around. I should not give the query all over again, describing each and everything how the output should come out. So it will have this contextual understanding with the help of the memory, and over time it will have the long term knowledge of what things goes on, and about the chat history and previous chats, and about the context which the user is speaking about. So this knowledge term also it will have. And coming to the personalization, again, we don't have to write each and everything all over again. once if I'm doing, if I'm writing about something, the model will understand what is the context, and it will give a personalized result only based on the initial queries which I've done, and based on the chat history which it has recorded. So that is how the personalization of this use case can be achieved. And it gets, the model will get continuity. If I'm asking something in the query 2 related to query 1, it will have this continuity about what the user is speaking about. So these are some plus points about using a memory. And coming to the type of agents, so one, we have a zero shot React, second one is conversational React, third one is React Doxer, and self ask with search. So let's look into each of these individually. So coming to this zero shot React, so this is agent uses, this agent is built in such a way that it doesn't have this memory component. It can give only one result at a time. If I want to do another query, I have to do the query description part all over again in order to get a proper desired result. So this is about the zero shot React, and it doesn't have any memory component inside it. When it comes to conversational React, the main differentiator between this zero shot and this conversational React is the memory. So it has this memory component to record all the previous conversations, and utilizes this memory in this way. And it uses this React framework to do the chatting with the user, or to do the conversation with the user. And coming to the third one, that is React Doc Store. This also uses the React framework to do the conversation with the user from the model. It has two different tools. One is search tool and one is lookup tool. So as the name indicates, or it's self-explanatory, this search tool is to get the data from some sources, and lookup is to fetch the relevant data and produce as a result. And this also will have a memory component inside it to store all the previous conversation, and to provide a context and personalization. And the fourth one we have here is self-ask with search. So this agent utilizes something called intermediate answering tool for self-asking question. So if there is a question or a query, if a user asks, so it takes that query, it analyzes it, and it asks a follow-up question to it. And to that follow-up question, it answers it gives some answer known as intermediate answer. So, and it does it several times until it gets a final answer. So that's the name self-ask with search. So these are about some types of agent. So let's do some code demo for this type of agents.
So, Rachita, I still had a question. So, this agent is tightly correlated or coupled with the LLM paradigm, or agents can exist without LLMs being in the picture.
We can actually, without having this vector store, and without having this text splitter also, we can establish this whole system. Without that also, we can do this just by giving instructions, and some descriptions regarding the data, and instructions regarding how to get the data, and how to get the data, for example prompt templates, and all those things we can put inside it. And without using this vector store also, this can run and give a better result.
So LLM has no tight coupling with agents. So agents can exist in isolation of.
Yes, yes,
Okay.
yes. So whatever I'll be showing in the code is without this vector store and without text splitter. It is just using it's just a picture of how it works without those two, and only with the instruction. So let me share. So let's okay. Let me stop this sharing. Can you see this VS Code, Vivek?
Yeah, yeah.
Okay.
You can increase the font a little bit.
It's, it's not
If it is
fine.
Windows PC, you can do Control plus.
Yeah, I'm doing it.
I mean, it's okay, it's readable.
Yeah. Oh,
This is a bit too much.
yeah, yeah. Got it. This is fine. Is this fine, Vivek?
No, it is back to where it was. Uh,
Okay.
it's one
This
level. This
this
is
one.
good. This is good. Yes.
Okay. So let's get started with the type of agents. So I have installed some libraries which is required like OpenAI, Google search results, Wikipedia, and SQL Alchemy. And this importing OpenAI and passing the this OpenAI credentials. And in the LLMs, I have passed the OpenAI key and its credential and some temperature if I want. And this is just to display the tokens left after each query using LangChain callback. And then for this, we can just create a small database just to um, have a look at how this agent works. So initially, I have this SQL Alchemy import the metadata, and I have added this column names like observation ID, stock ticker, price, and date. So just to just to use it as a column names for this small database. And this piece of code takes all the SQL lines in order to build a table. And I have added all this observation here. These are the observation ID, the stock ticker, the price, and the date. Uh, yeah, the date column. And then I have inserted all these things inside the table, and I have added this. I have installed this LangChain experimental. This has the LangChain codes for research and experimental purpose. So it's very useful, a library. And we have here the databases assigned to the databases which we have created before. And then coming to this first a type of that is zero shot react. So this is very simple. It doesn't have any memory component. It just gives a result, one query at a time, I can say. So in the agent executor, I have passed LLM, and toolkit is just the database and the LLM model, and verbose to be true to give more descriptions. And the agent type is the zero shot react description. And here we have one query. So the query says what is the multiplication of ratio between stock prices for ABC, XYZ in the January 3rd, and the ratio between same stock prices in January the 4th. So initially what it does, it enters to a new agent executor chain, and it observes and then it takes which is the agent type needed or noticed or mentioned inside this agent executor. So it considers this, and then it starts making the observation to which column or which aspect it has to look into, and then it does some thought inside this to get to arrive at some final results. So it does all those things, and it looks into the database. And this is how the tools works. It looks into the database and fetches the data from it, and then finally it gives the answer. So, and it also gives this token after this first query. So this is just to print what is happening under the hood, whatever I've explained inside this agent executor. The second thing we have is conversational React. So here we can use some tools such as math tool in order to do some mathematical operations if we feel the LLM is not up to the mark when it comes to the calculations. And we have a memory component inside it. We have chosen conversational buffer memory, and we have passed the chat history as well. And then we have and then in the query part, before the query, we have to push all these things inside this conversational agent. Agent type is this conversational React, and tools is this tool which has this math tool inside it, and the LLM and the memory part. And then we can ask the questions such as what is the result of the investment of an investment of $10,000 growing at 8% annually for 5 years with compound interest. So it takes this question and it starts this executing the agent chain. So the thought is, do I have to use any tool? So the question arises if it is yes or no. So if when it is say yes, so the action is taken and the calculator tool starts using the math tool, and it starts analyzing this query, and it does the thought process and comes up with a final answer saying this is the money that gives an answer for this question. Also, we can ask another question: what if it was instead of $10,000, what if it is $15,000, and give the difference between the answers for first query and the second query. That also it is able to do because of this memory component, that it has stored all the previous conversations, and it can use that for the next other upcoming queries. So do I need to use any tools? So yes. So it takes all the action input and observes and makes some thought process and give the answer. So the question is, what was the difference between those two answers? So it is able to give this answers that this much dollars is more than the previous scenario. So this is how the conversational React works. So coming to the React doc store. So here we have taken Wikipedia as the external source to be used. And as we have discussed earlier, this has two components. One is a search and lookup. So we can give certain instructions. This is simple instruction that I've given, or the description saying what it should do when it comes to this tool called search. So the search from the Wikipedia. So, and then we have a tool to retrieve the information, and this will do the lookup based on the query which is given by the user. So we have to pass all this again: tools, LLM, and agent type, and verbose and max iteration. So let's ask a question saying it should take the information from the Wikipedia. So the question is, what were the last words of Archimedes? So it enters to a new agent executed again, and it says what was it analyzes the query in the beginning, and then it will do all the observation. It will fetch using the search tool. It will look up all this information from Wikipedia, and using the thought process, it will analyze which is the word which the user is talking about. What is the user is talking about? So the user says, I want to know the last word. So it picks up this word, and with using the lookup, it says, and it start fetching for the word last words. So after doing observation, it comes up with the result and says, do not disturb my circles were the last words of Archimedes. So this is how React Doc Store works, using the tools such as search and lookup. And then we have self-ask with search, wherein we have this intermediate answer tool to be used. Here have added it. We can add more description to it as well. And we have some questions such as who lived longer, Muhammad Ali or Alan Turing? So the model asks within itself, is there any need to ask a follow-up question? So when the answer is yes, so it asks how old was Muhammad Ali when he died? So this intermediate answer tool start working, and it says, after searching from the Google, it says 74 years was his age when he died. And then again, there is a question called, where is there any follow-up question needed? Yes, because we haven't concluded any answer. So it is still a yes, and then follow-up question comes up, how old was Alan Turing when he died? So the answer comes up, and the intermediate answer saying he was 41 years old. So based on this follow-up and intermediate answer asked within itself, within the model, it comes up with a final answer saying that Muhammad Ali was who lived longer was Muhammad Ali. So there are many such questions. For example, are both directors of Jaws and Casino Royale from the same country? So again, follow-up and intermediate questions start coming up into picture until you get a final answer. So then answer comes up, no, they were not from the same country. So when the result is New Zealand and United States, it decides they are not from the same. It will do the decision process within itself and comes up with a final answer. So this is all about some agent types, coding part, or some examples I can say. So let's move on to this another example, wherein we are doing this LangChain agent using Bedrock. It's a specifically Anthropic Claude 2 model. So let's look into this diagram, this block diagram. So we have a user, and user will be giving an input from data sources. It will fetch all the data, required data, and we can have some API interaction. It is not there in this code, but we can integrate this with the system or this whole process. And then we have functions and chains or chains, and we have tool rendering to be done. And the LLM uses Bedrock and also Anthropic Claude 2 model. And then inside this agent, we have tools to do certain functionalities and to do certain specific tasks asked by the user. And in the prompt, we can have a prompt template, and it will a prompt template as an blueprint for the model to understand what the user is expecting from the LLMs. And we have LLM, and we have a memory component, and we have a scratch pad to store all those things which is done. Basically, this observation and this thought process, all those things will be done and will be stored in this scratch pad. So let's and everything is owned or overseen by this agent executor.
So Rachita, quick question. So
Yeah.
so the humans, how do they interact with agents? So is chat the default mode how we interact with agents, or there are other mechanisms to trigger an agent or interact with an agent?
So we can see this. Let me answer your question while I'm doing this part.
Mhm.
We'll have this clear idea. So for this code to be executed, we need Boto3 and LangChain, and we need LangChain experimental. And so here we are importing all those important libraries to be done. And in the model quarks, I'm adding this maximum token to be taking into consideration. And model ID is this Anthropic Claude 2. And inside LLM, I'm pushing all this client model ID and model quarks. And also I can have, instead the we can use the SQLite format of the data here. We don't need any separate server to, analyze the database here. So we can do this SQLite conversation using a small piece of code. Let's see that as well. So I have defined this CSV file, the current location, and where I want the destination, that also I have given here. And I'm reading the file, and then I'm establishing a connection with SQLite 3, and I'm converting that the existing banking data set which I have taken, which has these many columns like ID, so on. So it takes this particular you know this data set, and then it converts it into SQLite format in order to make it as a DB and to be analyzed by the tools. And I can give a name for the table here, and I can close the connection, and thus the conversation, this conversion completes. So I can add the same thing here, saying this is the database I'm looking into. I mean, I want the model to or the tool to look into. So inside this agent DB agent, I'm passing this LLM DB, that is DB, which is this database of this banking dataset, and then verbose, and then I'm passing this to SQL chain here, and this is just printing the contents of it, and this is just to make sure if the columns are read properly or not. So this is about tools, and this is where we can see the differentiator. So I'm importing the tool here, and we have SQL tool, and the name I can give for this tool is some banking I can give, and I can give some description. See, I'm telling the model that I'm forcing the model to take this point inside it, that you have access to this banking database, you have answer to all the queries, and you can run this tool when the input is instructions, when if in the query, if the word comes up that I want follow these instructions, so run these things, and understand carefully to all the questions and the user concern, I can say. And I can add so many things. It's like a teaching the small kid to do certain thing, do this, don't do this, like that. I can give a whole description inside this, and I can this should be done in a very systematic way, and sometimes it can throw some intermittent errors. Then we have to come back to this and do we have to tune this in a more understandable way for a model to take this into
You
consideration.
are creating the prompt command for the agent, right?
Basically, I can also give a prompt differently, prompt template differently. This is, let's say, this is just a description of how the model should think, or how the model should, go through. When the query occurs, or the query is asked by the user, it should have all these things inside the mind or the memory of it, and then come up with the result. So this is as that. And
Rachita, one question. So for this banking data set, so you are training, like you are giving some instructions to do some kind of predictions, or while doing some kind of queries. But earlier you didn't put any prompt, like the zero shot or maybe document search or some other. So what
which
is the difference? Like why
you're
we?
talking about this.
No. Earlier you shown like four lang chain agents, right? Agent types.
Uh-huh. So I'm putting
So
this here.
yes. So there you didn't train, I mean, you didn't put any prompt. You didn't create any prompt.
That
But
was
here,
just to show the examples of how the agent works with a small basic data set, which has hardly some 10 lines. So that doesn't need much of description, because it is way small, and no much description is needed. And we can use some math tool, because that becomes important, because that has lot of numbers. So in that case, a small example of a tool I had given, we can explore it furthermore if we.
okay, okay, sure. Got it. Please.
Okay, so I have also added a column summary, just to make sure the model takes it. I mean, it doesn't understand the ID in some other way. Uh, just like that, I have given the some description of each and every column here, and I can also give some template here, and I can and I can explain all those things about here, and I can also add some certain instructions inside it. When it is domain specific, this is just a small data set, but when it comes to a specific practical or real time scenario, we'll have to have so many instructions to it, and then we can combine it together, and that model can analyze it, and it can come up with a action. Like whenever it is executing some agent executor, it goes through all these instructions or descriptions I have given, and it goes one by one, and it understands each and everything which I have told as a user. If I am using this, I want certain output from it, so I'm telling that I want output like this, and it is different from the prompt, but it is more descriptive way, I can say. And I have added some math tool for calculation part, and then I have added a memory component just to get the context part, and then here we have used self ask with search, and we can put any query here. And then the most important thing is, as I said, it is when it comes to domain specific real time problem, we have to have more columns. Like we have to have a 2 3 prompts to be taking into consideration. One, we are trying so hard to push the model to think only in that certain set of instructions, and not go beyond that, or not to overcome or not to go out of the box, just because I am expecting something which is desired to only to me. So I'm pushing that model to only to put that virtual cap, and to go through only that particular set of direction, or such as instructions. So I can have more such things, and more tuning is needed in this part. I have to say that. And just by giving these three columns or these three instruction, it doesn't give. We have, based on the result, we have to come back to this prompt or this description, and what it is not working, we have to add that particular thing inside this tool, and then come up with the next set of results. So it goes on with so much of trial and error methods to come up with a proper answer. But when it is established, the results are really good. And we have this whole customized result, and it can satisfy the user. The responses can satisfy the user at the whole other level. So this is about this LangChain agent. And the next one. So coming to the conclusion, So the LangChain are, agents are the big step forward in making interaction easier to understand, and we can get the more connection is established within the model what is happening, and it is way more powerful. And as we discussed, as a key takeaway, we can say that we can get customized result, and we can use tools which are tools and toolkits and memory aspect, and we can use agent executor to handle all these difficult tasks. It makes it so easier and so fruitful, and the automation, of course, it makes it more efficient, and working with this will be much less of a hassle, I can say. So this is all about LangChain agent, and it is worth the hype. But the thing is, we have to we have to add the instructions. We have to add so many the things inside it, and we have to do so much of a trial and error method based on the results we are getting after each and every query. So that takes a little, a little time. But eventually, once we arrive at that point, it makes the process so easier. So that is all about LangChain agent. Thank you.
So in AWS, we find there is an Anthropic agent, right? So we know Anthropic has an investment from Amazon. So naturally, Amazon is pushing Anthropic agent in AWS Bedrock. Now,
Yeah.
is it possible for us to implement non-Anthropic agents in AWS using our own
Uh,
code?
yeah, you're talking about the model, this Anthropic Claude.
Yeah, instead of Anthropic agent, what
We
if I
can
want to do Mistral agent?
we can do Mistral, we can do with Llama 2. Like the model, based on the performance and based on what we are expecting from the model, how the output should be, and based, sometimes it is also based on the number of tokens available, maximum tokens available. So based on that, we can choose any sort of model, but
What,
agents will remain same.
what about GPT based
We can,
agent?
OpenAI also can be used in here, as in the, you can see in the first code of just agents, I have used OpenAI. So we can use GPT. Yeah, yeah. The model can be anything, but the process of initiating this agent and everything remains same based on the performance and based on the expecting from what is expected from the model. So based on that, we can
So,
play.
Rachita, are we foreseeing a future where every corporate workflow will become an agent? Whether a couple of marketing agents, human resources agents, manufacturing process agents, will everything become an agent in future?
Definitely we can go in this direction as well. uh, like it is all about playing with the rules and giving instructions, and as I keep saying the same thing, it push the model in certain direction. If we have a domain specific problem statement, we can dig it entire to that topic, and we can upload all those things, or write in the format of text and put everything inside this agents as a tools, and we can render it, and we can add all those tools while taking the output. So in any domain, this works good up to certain up to certain level, but the tuning is always needed to get near to perfect result. But
Mhm.
this goes very well with all domain. This is actually for, I can say, this works very well for the domain specific thing, because unlike the normal LLMs, it will have the all other information inside it. But when it comes to agent, I'm making the domain specific, the agent itself the domain specific to, I'm like making that agent as some let's say a mechanical engineer, like act as a mechanical engineer. It was it before in the chain of thought, we can just act like a mechanical engineer, or personalization of prompt template. You can just act like a mechanical engineer and answer the question. So but in this, we can add a whole description to it, each and every aspect of it we can add inside it, so that in that way it will be more fruitful in each and every domain.
Hello, Rachita. I have one question. Thank you for this presentation.
Yeah.
Could you please jump to the calculator example? I'm not able to comprehend the idea where why we are passing LLM and then we have the tool. So,
This
The
one.
calculator example, I
This
think
one.
it's
I have
second
not.
one. Or
Yeah, I have not done any calculation because it was a banking related data
no,
set.
no,
I
no,
might
not this one, not this one. I think it's in
this.
the example where you were explaining four different types of agents,
Yeah, yeah.
not the one where the SQL alchemy is used. So
This one.
yeah,
LLM.
So you have used LLM math here. Now, could you please scroll down to the next cell? You
I have entered tools here, which
okay.
takes this aspect. So this is just, we know LLMs can do, math
Hmm.
based on the type of the model. But when we
Hmm.
are not sure about the, sometimes it doesn't give, it starts throwing intermittent errors. So at that time, to make sure this doesn't happen, we can add such tools. We can actually, this is just a basic thing. We can increase this, you know, we can add more code part to it in order to make it more complex, to in order
No, no.
even.
My question is more towards the interaction between the logs. Can you show the logs where it's like, do you need a calculator and it says yes? So I'm trying to understand that particular part.
Okay, so
This one.
okay, so
So. Mhm.
there is a question to calculate the what is the result of investment
Mhm.
like $10,000 growing at 8% annually for 5 years. So with the component, so it is asking the
Mhm.
what is the result of this investment. So to do this, I have to have a calculator, or I have to do some math, so that it analyzes that I have to do some math here to in order
Mhm.
to arrive to some result. So in that case, this agent says, I want to use any tools, so it says yes, and then action says I am using the calculator.
Hold on a second here. So do I need to use a tool? So this answer yes is coming from the LLM, the OpenAI LLM, or there is the agent that is answering itself, because you're
So I have.
passing LLM as well in the parameters, like when you're initializing the agent.
Yes. So yeah, as I said, this is just a basic example. I'm ensuring this math functions should, or this calculations will go, in 100%. It should work. So I have just as an example, I have added inside the tool. So this conversational agent takes this tool which has the calculation part, and it also takes the LLM which is OpenAI, and does everything.
So
So
it's a wrapper. This tools is nothing but the name of a tool. It's a wrapper of something, some tool. Based
yes,
on that, we have to put that specific name, right?
yeah.
Yeah, yeah. And can you share some resources to practice or to try this type of writing methods of
Uh,
all of these agents?
I don't have it right now, but you can share the email to me. I can provide it in within a half an hour. I have saved it somewhere else, so yeah, we'll be sharing that to you.
Sure.
I have
Okay.
good resources. Yeah.
Sure.
Vivek, you can take over.
Yeah, good presentation. So I feel that this agent is a new paradigm for most of us, and
Yes.
we were barely beginning to learn LLMs. And
Yeah.
even before we could master LLMs or a semblance of it, now we are hit with lots of new, angles to this whole generative AI space, including this, agent framework. Because agents mean think of everything you do in a company or personal life can be outsourced to an agent, literally. So, so I think we need a lot more content and webinars on this.
Yes. Yes.
But good discussion there, Rachita.
Yeah.
Audience, any other questions for Rachita?
Hey, one question. Is there a way to set the data level security? Like, since we are passing some data to LLM, it's scanning through all the data and start answering. So when somebody asking the question based on the role or user, it should pick certain data only to answer the question. Is there anything like that?
I can specify. I can see. We can add multiple tables also, databases also. So I can provide different names for each thing, and I can ask the tool to to use only certain databases to answer the question. That also we can do.
Ruchita, I think what the question is that the table that you gave, whichever table that you gave, can have data of many other people. I can trick by asking a question, get answer for someone else's data. How do we ensure that that does not happen? I think it's going to be a custom coding to
Yeah,
prevent that.
yeah. We can add everything inside this description only and inside the instructions to get it done. It will follow. It will definitely follow all the instructions when the query runs.
Okay, thank you.
So Rachita, whatever resources you are going to share, you can put it in the AI lab group because many people want it. So you can put it in the, and if any of you are not part of our AI community, do reach out to us. So we can give you, ways to join the community.
Yeah, and also we have several other webinars lined up, and you can find so many other webinars from our YouTube channel. And there is another webinar on Anthropic, which was done by Indrajit. That was so resourceful. You can go through it, and there are many more, such useful contents, to enrich our. Because as I said, this world is all about generative AI now. It can, do some. Mostly it was difficult before when you consider the traditional methods before, but now with the generative AI, it has become so easy. I mean, so easy to understand and to tackle. So you can find varieties of content and useful contents. So you can go through all those uh, materials, I can say.
So I think it will not be feasible to send to individual emails. So we'll put it in the AI lab group. If you are not a member yet, to reach out to us. We'll give you options how to become a member of our AI research group. Any other questions for Rachita? So I do feel a lot of work is needed in this agent. So it's a new start for us. Yeah, go ahead. Sorry, somebody was asking.
Yeah. So Rachita, I have one question. So can I use this LLM chain with Gemini without using AI or
We
any
can.
other? We can, right? Okay. Because I'm planning to integrate with Elasticsearch or MongoDB.
Okay.
And also I'm planning to inject more, like more than 50 GB data. I just
Got
want to do some experiment. Like I'm
yeah.
going to train the, once I have all the data in MongoDB or Elasticsearch, I'm just planning to instruct, okay, use these tables, use these columns. And
Yeah.
on top of that, I'm planning to ask few questions, like I just want to see how this work, and is there any chance for hallucination, or is there any chance to misses
So
the like
when
there is.
we talk about LLMs, it actually comes with the topic of hallucination. But yeah, we can and to some extent we can avoid this problem. Yeah, that's what when we put it into certain boundary, it will stop going out of the box, and it stops hallucinating. And unless we don't have a data, it won't hallucinate. Basically, that's the basic answer I can give. But this using this agents with a set of instructions, it can think only in that box, and provide some useful answers or responses to your query.
Yeah, of course, it is having like a long-term memory option,
Yeah,
right? So agent.
yeah.
So yeah, okay.
So that's an interesting idea that agents can help you control LLM hallucination.
Yes,
So you
yes,
set up boundaries of how you allow LLM to operate. So
yes.
it doesn't go haywire with hallucination.
I can give some instruction that with outside this database, don't take any kind of answers, or don't provide or don't generate
Like,
any kind of answers. Up to some extent, this will be taken into consideration when we talk about hallucination.
but still, there are a lot of challenges, like scalability wise,
Yes,
or
lots.
performance wise.
And along with this, fine tuning is very necessary. If we
Yeah.
want to establish this as a full-fledged product.
Yes. Because in our previous project, previous company, so we have like almost 2 terabytes of data. On
Okay.
top of that, they used, I believe they used LangChain only. but I don't know the exactly like what exactly they did and what kind of plugins they used in order to connect to Elasticsearch. So
Got it.
I just to explore. Yeah,
Got it.
thank you. Yeah.
Yeah. We'll be sharing all the resources soon.
A quick question. Have you tried doing a memory consumption map for a conversation to know a typical conversation which is run for, let's say, 4 dialogues or four
Uh,
exchanges? How much of a memory is being consumed, and if needs to be scaled to, let's say, 100 or 10,000 people in a session, how much memory does it consumes?
I haven't done it yet, but we can do that. That will be the some insight in order to analyze what is the consumption of the memory. But I haven't done it in this product or this code demo. But that is necessary because when it comes to a
Got
corporate level, everything which reduces the cost is important or vital.
Indeed, to productionize it for sure, it is a very key question to be answered.
Yeah.
Anyways, thank you.
So Rachita, this in addition to LangChain agents, can agents be developed without LangChain? And how about Llama Index? Is that a competing tool or a totally different objective?
It can be a similar one. I have to explore on this more, but it is possible.
Got it. Thank you. Any other questions, folks? Okay, so thank you all for joining this Saturday. And thank you, Rachita. Excellent presentation.
And thank you
We
for
need to
being.
do a lot more research into agent, new paradigm to learn.
Yeah.
Good work, Rachita. Thank you all for joining.
Thank you, everyone.
So we do have our second class of our GenAI course Sunday morning India time. So do join us there. Thank you, Rachita. Thank you, audience.
Thank you.